I'm your host, Zach Dutton, and welcome to Science on Wheels. Today, we're going to be addressing why the sky's blue, why sunsets are red, why clouds are white or gray, maybe even why rainbows happen. But all of that and more coming up right after my car wash. Alright, so what makes the sky blue? Well, just like really a lot of other things in science, it starts with the sun. Now, sunlight, even though when we make drawings as kids we make it yellow, sunlight is truly white. Now, white light comes from it being a mixture of all the colors of light, all the different wavelengths of light, because color of light is measured in wavelength. So white light is a combination of all of those different wavelengths, all of the colors together to give us white sunlight. So now we think about, well, why is it blue and not white, I guess? Well, that comes from what happens with that light. So we always have particles in our air, different atoms, of course the main ones being nitrogen, hydrogen, oxygen, of course carbon. Now those elements, those particles in the air, actually absorb that white light, and they absorb the white light and take in that energy, and then the photons within the atoms basically re-emit the light in all different wavelengths. So it still gives off all different colors, giving us that white light. So the white light from the sun is absorbed by the photons, and then they just basically give it off again. The question as to why the sky is blue can be explained how the light is scattered. So when it's re-emitted from those particles, it bounces into other ones, and then red, for example, doesn't scatter very far, but blue happens to scatter the most. So because blue scatters the most basically across the entire sky, that's what we see. So we see that blue sky because the white light is absorbed, re-emitted, and then scattered. Alright, so that explains to us why sunlight is blue during the day. But that begs the question, why do we not see a blue sky at sunset? Well, for that we have to turn and look at our atmosphere. So, during the day, the sunlight is overhead. And up there, the atmosphere is a lot thinner. But at sunset, the sun is much lower on the horizon. And when it's lower on the horizon, the atmosphere is a lot thicker there. So that thickness has to do with why the sunset is red. So because the blue light that we were talking about earlier doesn't have a whole lot of energy behind it, it's not able to get through that thicker part of the atmosphere. So the red is transmitted through that thicker part of the atmosphere because it has a higher energy. And when it's transmitted through, the blue light has essentially already scattered off. So what happens is the blue light got scattered off because it didn't have a lot of energy. But now the red light is transmitted through that thicker part of the atmosphere, and it's able to pass through there, and that's what we see at sunset. So the thicker atmosphere requires more energy, which the red light has, to be transmitted through the atmosphere. So now, why do we see white clouds and gray clouds? So clouds are made up of water droplets in the air. So those H2O molecules kind of form together and together and together and become bigger into larger water droplets. And these larger water droplets get together and form a cloud in the atmosphere. So now, it really depends on the amount of H2O. So white clouds are made up of really small water droplets, and they're white because when that white sunlight comes in, similarly to why we see a blue sky, that white light comes in and it's reflected and refracted off of those water molecules that make up the cloud. But because they're really small, it scatters all the light and we see the white clouds because, again, sunlight is white. Gray clouds, on the other hand, are made up of much larger water molecules. These larger water molecules don't reflect the sunlight as much as they absorb it. So the sunlight comes in and is absorbed by those larger water molecules because they're larger, and therefore the sky is darker because there's not as much light passing through those water molecules. Lastly, why do rainbows happen? Well, it only rainbows after rain. And that is because the water molecules that came down in the precipitation are still kind of in our atmosphere. Now, because they're in our atmosphere, the sunlight still comes in just the same way it does any other time. But the sunlight comes in and it hits those water molecules. Now, it's coming in at the speed of light, but when it hits those water molecules, it slows down. Now, when it slows down, each wavelength slows down at a different rate, which shouldn't be terribly surprising. So when they slow down at different rates, that is what separates the colors into the layers, that Roy G. Biv that we've come to love and know. Now, it separates because it's slowing down at different rates there, and not scattering all at once like white light would, or else we would just see that blue sky. And now that I've arrived at Nick Tahoe's for lunch, I appreciate you riding along and learning something with me. But for Science on Wheels, I'm your host, Zach Dunton, and you have a good rest of the day.